you kidding me? That's terrible. Okay, so the big thing today is just understanding this notation, and the bad thing is I printed these out for you, so now you don't need to practice writing your sigmas, but you are going to have to write them at some point, and it's basically just like a really pointed E, right? Here's my sigma. Not so great, but it works, right? You'll be okay. It's kind of like a sideways M with some extra little things at the top. Math people love Greek letters. They're our best friends. Like pi. Pi is a Greek letter. You don't think about it, but it is. This is my favorite Greek letter. You know this one? Mu. There's a shirt you can buy that has a cow and it has a little thought bubble and it just has this in it. And if you don't know what means mu, you're like, I don't understand that. But then you're like, mu. It's like moo. That's cute. Basically, the difference between a sequence and a series is a series you add up the numbers in the sequence. So we want to find the sum, right? When we see this, we say the sum of whatever the formula is from 1 to whatever n is. So n will be a number. They use k in this one, but you can really use whatever letter you want. They use n a lot, they use I, they use j. You really can use whatever letter you want. I don't really recommend using x, but you could, as long as you label it correctly. N is where to stop. So if I said from 1 to 100, that would mean I would want you to add up the first 100 terms of the sequence. If n is 5, like in number 1 here, I would want you to add up the first 5 terms. Normally this starts at 0 or 1, but really you can start wherever you wanted it to. It just depends on the problem. Okay? So let's just jump in here and see what we can do. Find the sum. So you got to know what this means. It means start at 1, end at 5, all the numbers in between, all the integers in between, and this is your formula. So do you agree if I plug 1 in here, I would get 3 times 1? Yes? And I'm going to keep going until I get to my upper limit. So then I'm going to do 3 times 2, because that's what comes after 1. And then I'm going to do 3 times 3, and I'm going to do 3 times 4, and I'm going to do 3 times 5. Plus 3 times 5. And why do I stop at 5? Because this tells me to stop at 5. And then I just add them up. You with me on that? So then I would get 3 plus 6 plus 9 plus 12 plus 15. Right? This is like the explicit formula. It's saying for whatever n is, you just multiply by 3. And I think you get 45. Which means the sum of the first 5 terms of that sequence is 45. Yes, no, maybe. Doesn't seem so bad, right? Some cool Greek letters. So what if the formula looked a little weirder? Like the next one. Like plug your numbers in, right? Not going to be that much worse. Not today, at least. So on this one, same idea, but there's 2 places to plug k in, and you're just going from 1 to 4, but you have to plug 1 in for both of those k's, then add that to plugging 2 in, then add that to plugging 3 in. Because I feel like lots of people are asking. Is Courtney ever coming back to school? She's not going to do that ever. Not to me. I have this whole packet for her. We're going to school tomorrow. This will be done all next week. And I have a whole packet. Courtney, I have a whole packet. I'll give it to you. Right? Watch your multiplication. This would be negative 1 times 2 plus 1 times 4 plus negative 1 times 6 plus 1 times 8, or negative 2 plus 4 minus 6 plus 8, or 4. Oh, you had to stop where it says to stop. Yes, no, maybe? Kind of maybe? Any clue what I'm saying? Well, what else could I you. Instead of having you add it up, what if I gave you the sequence and asked you to write it in sigma notation? Which is kind of fun to say. Write the sequence using summation notation. It's like a Dr. Seuss. So this is a sequence that we did yesterday. Well, not the one we did, but like we did yesterday. 8, 13, 18, 23, 28, 33. What are you doing? Well, actually, we'll even talk about the pattern for a second. Let's just do our sigma stuff. Let's write sigma. And every time you're going to write your sigma, and your top number is going to be how many terms are in this pattern. How many terms are in this pattern? 6. 1, 2, 3, 4, 5, 6. That's my top number. Your bottom number, technically it could start with different things, but the easiest thing to do is make it start with 1, and you can make it whatever letter you want. We can use K, we can use I, we can use J, we can use N, we can use Q, whatever you want to start with. What do you want? N. Let's do N. Good choice. We use W in second hour. Because we're going to start with 1, we're going to end with 6. You with me on that part? Now the other part is the formula. We did this yesterday. When they want you to write this, they just want you to write the explicit formula. So looking at this, what are we doing to go from 8 to 13 to 18 to 23 to 28 to 33? What are we doing? So is that an arithmetic sequence or a geometric sequence? Arithmetic, you have a formula for the explicit formula for an arithmetic sequence, which is a sub n equals a sub 1 plus n minus 1 times your common difference. You don't got to memorize that. You just got to know arithmetic. And do we know the first term? Do we know the common difference? Which means we can write that formula. And notice, I picked n because that's what's up here is n. If you use j, then you need to make sure your formula has j in it. But I'm just going to work this out now. So I get n minus 1 times 5, or 8 plus 5n minus 5. Or what would that be? 5n plus 3. That's my formula. So I write it over here. 5n plus 3. Or 5k plus 3 if you wanted to use k. I don't care what letter you use, but whatever letter you use here, it has to be the same letter up here, or otherwise it doesn't match, right? It doesn't tell people what to do.
That formula, is it the two ones that you gave us
Yesterday.
Which one is it?
It's the explicit formula for arithmetic because this was adding. If this was multiplying by 5 every time, I'd have to use the explicit formula for the geometric, right? Like you have to figure out whether it's arithmetic or geometric to know which one to use. Yeah, because the other one you have to write out the first term and all that. Yes, it's always going to be the explicit. And you can check that you do this. If we plug 6 in here, 5 times 6 plus 3, does that give me my last term? Yeah, so it's kind of a nice little check that this would be the summation notation for that problem. Yeah, so kind of, maybe. So that's a lot of the homework today. But what if I asked you to add up like the first 500 terms of a sequence? That would be awfully mean, right? Because you got to be like adding on your calculator. Unless there's a formula, which there is. Oh my. Again, you don't have to memorize these formulas. Some people in second hour, because they're crazy sometimes, and they like to get a head start, and they already have been worried about making their formula sheet out. And they say, can I write this on my formula sheet? And the answer is yes, but here's the rules for my formula sheet in case you know over this long weekend that we're going to get a blizzard and you want to get a head start for your test. On your formula sheet, it has to be handwritten, no typed, no photocopies, handwritten by you, handwritten, only formulas, which means no examples. But you can write all of this. Like you can write the name of it, you can write what it is, what the letters represent, but you can't like say, and an example of this formula would be this problem. Follow me on that? We'll talk about that more before the test, but some people wanted to know about it today. if you have an arithmetic sequence and you want to find the first so many sum numbers, you don't actually have to sit there and do it. There's a formula for it. So here, there's actually two formulas. This formula, you take n, which is the total number of numbers up there, times the first number plus the last number, and you divide by 2, and it always gets you the sum. Pretty cool proof to go with that. I'm sure you're not interested. But it's like you add up the first and the last, you divide by 2, and you multiply the number of numbers, and it tells you the sum of the sequence. So on your test, I always give a problem that make you add up like the first 100 terms, and there's always someone that sits there with the calculator and adds up the first 100 terms, but you should just use this formula, right? So this is if you know the first and last terms. This formula is great. But what if you don't know the first and last terms? What if you just maybe know the first couple terms, and you know you want to go to the 100th term? This is another formula that you can use. N is still the number of numbers, A is still the first term, and D is your common difference. So if you don't know the last term, that's when you'd use the bottom one. Or you could use the bottom one whenever, I guess, but definitely a little bit more work. Number 4 is kind of silly because I know you could just add this on your calculator, but I just want to show you that it works. If it says, find the sum of this sequence, honestly, you probably could plug it into this formula faster than you could put all that on your calculator. And I don't really want to race you, but the formula is really quick. This formula will add this up. So I just need to know the number of numbers, which is 1, 2, 3, 4, 5, 6. And I just add the first number plus the last number, and I divide by 2. And it doesn't matter how you do this. I always just think about that would be 3, and 3 times 6 means that if I added those up, it would add up to 18. Obviously, you don't need the formula for that problem, which is why on the test I make you do like a really high number, like the sum to 100, because I want to know if you use the formula or if you take the time and right. What about the next one? Is there a next one? Yeah. So what if I wanted you to add up 2, 4, 6, 8 all the way to 70? Definitely you could do that on your calculator, but the idea is that the formula will be faster because you take the number of numbers times the first plus the last divided by 2. On this one, we know the first and we know the last, but the trickier part is the number of numbers. But you should be able to figure that out on this one, right? Like if this is the first number, so if this is like a sub 1, and this is a sub 2, and this is a sub 3, and this is a sub 4, what term is that going to be, Trevor? Because we're just doubling it every time. Follow me on that? Just 2 times n. So this would be a 35, which means it didn't tell you there's 35 numbers there, but it's not a really hard one to figure out that you should be taking 35 times 2 plus 70 divided by 2. What'd you get, Bryce? 60? That's definitely faster than adding that up on your calculator, right? Yes. Okay? So arithmetic sequence, if they give you a sum where you're adding every time, then you use this. We also have a formula for geometric sequences. That's if you're multiplying by the common ratios. So the sum of a finite geometric sequence, this is where we have a typo here. This should be a minus sign, so everybody should fix that. Minus, not plus. It turns out that on number 6, we did it with the wrong formula, and we got the right answer, and so, I don't know. But it's supposed to be minus, so we're just going with it. These can get kind of weird, and a lot of times you get decimal answers. But it's still the first term, and instead of D, we're talking about the common ratio. N is the number of numbers. So think about if you were going from 1 to 100. You take your R to the 100th power, so these can get really big, divided by 1 minus R. So look at number 6 here. It says find the sum of the geometric sequence, and they write it out like this. And notice they try to help you out. The way that they write this is instead of writing this term as what it actually would be, think of 1/6 to the 8th power. They write it like this to try to help you figure out what term you're on, figure out your ratio, and your first term even. So let's start with the common ratio. What's the common ratio on this? Well, this is where you kind of need to know your formulas. For a geometric sequence, isn't it a sub 1 times r to the n minus 1 power? Right, I just need to be vaguely aware of that. So let's start with a sub 1. What's the first term? 42. And notice in this last term there's a 42 in front because they're writing it in the formula. What's your common ratio? What are you doing each time? You're dividing by 6, so that makes your ratio. Notice, that's right there. And if this is 1/6 to the 8th power, what term is that in the sequence? 7, 8, 9. Those are our choices here. It's always the n minus 1, right? So if I'm on the 10th term, the exponent would be 9, right? So if the exponent's 8, do you agree that you're on the 9th term because 9 minus 1 is 8? So that means you're on the 9th term. You got to be really careful when you type this in your calculator because it really matters where you put parentheses here. But we would take 42 times 1 minus 1/6 to the 9th power all over 1 minus 1/6, which is just 5/6. Put on the bottom there. Order of operations, exponents first, right? But you should be able to just type this whole top on your calculator and then divide by 5/6. If you type it in all at once, make sure you put the bottom in parentheses as well. I think it's supposed to be like 50.4. That didn't work out like that. 50.4? $50.399995, which I just rounded to about 50.4. I would recommend I do the top and then divide it by 5/6, but I can help you with it later if you need to. Some people have a problem with that because they're like, if you just add the first 2 together, you're already at 49. But if you keep dividing by 6, do you agree? Each term becomes really, really small, like smaller and smaller and smaller. So that's why you can say that it's not really that much more than the first 2 terms added together. Maybe. Let's see if we can. Let's skip this one. Same rules, but on your homework, it's not going to always say arithmetic or geometric. On your test, it's not going to always say. So you've got to look at it and decide, is it arithmetic or is it geometric? What are you doing each time on this problem? You're multiplying by -11. If you're multiplying, it's geometric. R would equal -11 in this one. So if I'm doing geometric, I know I'm doing that a sub 1 times 1 minus r to the n over 1 minus r. And they tell you on this one that n equals 9. And you have the first term, right? So if you recognize it's geometric, you have your formula, you're just plugging it in. And that's what a lot of this chapter is called discrete math. A lot of discrete math is just using formulas and plugging them in. You really want to be careful on this. People really like to cancel negatives out. And on the bottom, 1 minus -11 is just 1 plus 11, which is 12. But on the top, order of operations matter. Exponents before adding. So you cannot just make that a plus, which people really want to do. be careful on that, okay? Because if that was an even exponent, things could change. So I just want to caution you to just not cancel things out. I think it should be a really, really big number. Because think about on this one, although it's alternating positive and negative, if we keep multiplying by negative 11, we're going to get really big numbers here. 1 minus negative 11 to the 9th power. I forgot to divide by 12. Did you get a negative number?
Yeah.
Negative 196495641. That's a lot. So a lot of formula stuff. Dang it, Chloe left and didn't get a worksheet. This is your homework. So here's the thing. If we have school tomorrow, which I hope we do, this is what to do tomorrow. I'm going to go ahead and give you the worksheet that I was going to give you today that I switched to tomorrow in case we don't have school tomorrow. So this worksheet that I'm giving you is due Monday. Whether or not we have school or not, on Monday this worksheet is due, which that would be due also on Monday. This worksheet is over 9.1 to 9.4, so it kind of just gives you a review. I'm going to send two back for you and just in case you see it. Okay. So you have 2 assignments, but you really don't have to do 2 assignments tonight. All right, if we have school tomorrow, this worksheet is not due. You will just work on it in class tomorrow. Does that make sense? I just switched it around because I didn't want to do a worksheet today and then miss school tomorrow when we could have done a lesson today. All right, so I'm just trying to prepare so we can actually have a test session. Test corrections are due tomorrow. Obviously, if we don't have school tomorrow, they would be due on Monday, and you could still retake that test on Monday. But that means today, tomorrow if we're here, Monday.
For the interruption, we have some